Hey, I'm Taylor Dorsett, and this is the Professional Technical Interviewee. Technical interviews are hard, and every company does them differently. On this show, I interview engineering leaders to see what they look for in technical candidates, and then they perform a real technical interview with me. My guest today is Roosevelt Anderson. He's an engineering manager at Dividos and previously worked at Grainger, Jellyvision, and Amazon. We talked about the importance of asking questions in interviews, his approach to the take-home interviews, and work on a two-dimensional array problem during the technical portion. Welcome back. Roosevelt, the ball is in your court. Time for the technical portion. Let's make it happen.
All right, cool. So I hope you haven't done this one before. It's a simple problem to represent, which I like. So just like to see how you get a solution to it. Given a two-dimensional array, represents a maze, print the path of the maze. The inches of the maze will always be in the first row of the array. The X will always be in the last row of the array. For this exercise, assume there's only one valid path. And I also forgot to put in ones or walls, zeros or free space.
Okay, great. I will let you know, two-dimensional arrays, these types of building array questions are some of my the ones I struggle with the most. So this should be fun.
Okay.
What's the expected result if the outcome is true? Is just true or false?
Just print the path. If you can just return the path of the array indexes.
The indexes of the path.
Yeah. If you can do that. So it would be 0, 0, 1, depending on language. So I'm thinking zero-based arrays. It would be 0, 1, and then it would be 1, 1, and then 2, 1 would be the first kind of free spaces here.
Yes.
And then
These
and then
zeros,
kind of
right?
That way. Yep.
Okay. Great. Okay. Interesting. So that makes sense to me, and we want to print out the path. Let me pull this. Is there a...
So I put both array types in. I did the Python one, and then I did one that should be compatible with JavaScript, I hope.
Yes. I think this first one should work. Maybe... oops. There we go. That should work.
Okay.
Just declare it. Okay, so I'm trying to think of where to start with this. Obviously, I can build my my function, but with two-dimensional arrays, part of the tricky part for me is visualizing. Obviously, what has to happen in the code is different than how it works in my brain, which I think is the difficult part. I'm thinking of working my way through this. In my mind, what makes sense is if we want to basically loop through our arrays. In each array, we want to basically note zeros, right? So if it's a 0, that means a potential correct path.
Yep.
And then how we can continue through that is if 0 basically aligns with array above, that means we can continue with that path.
Yeah.
Does that line of thinking make sense?
Yeah. So I did make this one easier. So there's only one entrance and one exit.
Okay.
So that'll give you a hint.
Yes. So there's only one entrance and one exit, then we shouldn't have to worry. Basically, are there dead ends?
Yes.
There are, right? There are.
Yeah.
Okay. Interesting. So I guess this portion isn't exactly true, right? It's not if it aligns with the array above, because sometimes we're going left and right. So I think how to basically, we would need to track, or basically how to track if we're continuing to move in a correct direction. I'm trying to get the best way to do that. Hmm.
So let's just kind of talk through it.
Yeah.
So how would you first start off? So I did actually make it very, very, very easy.
Mhm.
As opposed to so because the entrance is always on the first row, right?
Yes.
All right. So how would you just find the entrance? Let's start there.
So just looking for the zero. So there'll only be one entrance and one exit,
Yes.
right? So we'd just be looking for the zero on the first row.
Yep. So let's start there. How would that code look?
Entrance, find zero on first row. Okay. What do we want to call this? Maze. Input.
And by the way, this doesn't have to be syntactically correct, or it could be pseudocode too, because I know we don't have a lot of time. So I really don't hold that against candidates.
Yeah. Okay. Great. So it makes sense to me. We want to loop through each array. I guess in my head, I'm trying to figure out if I would make some type of for loop, or I would use some type of for loop, but trying to think if we need any type of nested arrays, which I think would be a slower solution, but the one that immediately comes to mind. But if we're doing for let next equals 0, I is less than array dot length, then I puts 1. If so, that only gets us into our initial loop. So that's what I was thinking. We might need nested loops.
So this particular problem, I chose this particular problem because normally on a problem like this, you would need nested loops. You do not.
Okay, great. That's good. I guess I don't actually need another.
So with what you currently have there, that'll never evaluate to true.
Right. Because it's just going to get into this, but it's not actually going to iterate through the actual.
That's only actually going to return you an array.
Right.
With value written. So knowing what you know, it's the first row. Do you need to even? You still want to iterate through just the first array, the
Yes.
first array in that array.
Right. If I'm hard coding, I would use something like that. Right. I just want to go through the first one. Right.
Yeah.
So if that equals I, then basically if it equals 0, right, then we have found the entrance, which would need to indicate movement or something like that. I guess we could have variables that are something like horizontal 0, let Vertical. You can't tell I'm not a great speller.
Yeah.
If you don't hold the pseudocode against me, I hope you won't hold the spelling mistakes against me.
So let's actually just make it a little bit easier. Let's just break it up. So let's just find the entrance to the array first. And then once we find the entrance, let's do a next function or a next block of logical code to kind of find the path.
Okay.
I think that would probably make it easier.
I think this would, it's going to loop through this array. It's going to look at vertical, which is 0, right? This first one, if I equals 0, then it'll return true. So I believe this should return true. Oh, we want to return the index. Return would be
you should return I. Because then you're just looking at the column. So you already know that the row is going to be row 0.
Right. Oh yeah. Okay. That should return our entrance, right?
That's going to return the value, not the actual index.
Oh.
Yeah. So this, you just return I.
Yes. Right. I was thinking we got to call index. Oh, if we don't, because this would represent 0, 1, which would be the first one.
Yep.
Right. Okay. Great. So that's the entrance. Or will return the entrance. So then I think the next basically step in my mind would be we need to decide where we're going to move. I guess for the entrance, can I assume that we'd always be moving down from there or south
for this example, yes.
Okay. Great. So that's where these started to make sense to me. Like basically we would vertical plus equals 1. Right. So now we're going to increase this by 1. Now that we found the entrance, it would increase this vertical by 1, and then now we'd be looping through the second array.
Okay.
How do you feel about that approach? I think we'll run into some issues later, but
okay. So if you're going to loop through, how are you going to track what's connected? So in that second array, you're going to have, it's going to return true for, what is that, 7 values?
Right.
So how do you know that that's connected to my entrance?
Yeah. That's a
By
good
the
question.
way, as soon as you solve this problem, you'll be able to solve any problem like this.
Really? Okay, great. Well, these are the ones I think because in my brain it works like so differently, and I think I see it differently than when I'm looking at it in code, which is like, how do I have to actually move through this? I don't know. The best way to track movement, or basically what's connected, we could store some type of variable that's basically like last path index or something like that, or last path value. Would that work?
Yeah.
So if in the same code we would have let's go last last path value equals, I'll just path value equals. I guess I would want. So that'll be the last path value. So then when we move to the next one, we would still have that stored. Again, this verticals thing is going to have issues because, well, I guess in my head, this vertical horizontal, the way that this would work is basically if we get to a spot where this is the first one, it would be an issue, right? Where when it moves down to line 14, last path value wouldn't align with the 0 on this one. So then this would be changed. There's some type of if check to change that to horizontal, right? So then it would start checking horizontal. I don't think that really works out from a code perspective all that well, but
Doesn't it?
it maybe, I think, oops.
So what you're describing,
Yeah.
there are actually two ways to accomplish what you're describing. If I tell you a key phrase, and I think you'll get it, but I kind of want you to kind of think through. Make sure, so you want to output the path on it, correct?
Yeah.
All right.
So, no, go ahead.
Yeah. So how do I, back your mind, how would I track the path to output that?
Yeah, I could basically put this value into an array, right? Each value could go into an array. So then the path, basically, we could return an array at the end that would be 2, 2, 2.
You're on the right path. You definitely want to store it in a data structure, but is there one that's more optimized for kind of what you're doing?
Yeah. Well, I was going to say a hash, which makes more sense to me if I'm trying to track not just the index, I also have to track which array it is in. So the key could be.
The thing is, I only care about the indexes on the two-dimensional array. So if you stored it as a hash, how would that actually look?
I was thinking basically the hash would be something like, let's say for this first one, it's 0, right? Which is the array, this first array, right? And then the value, which is 2. I don't know my JavaScript syntax for hashes, right? But then the value would be 2, but I think we'd have issues with that once we're trying to go horizontally, because there'd be more than one 0 key. Does that make sense?
Yeah. So let's take it back a little bit. All right. So we found the entrance, right?
Yeah.
Taking the naive approach, what would be your next step to find that next 0?
It would basically be to increment into the next array.
So go into the next index.
Yep.
All right.
And then start looping through these values again till we find a 0.
What do you need to loop though?
Oh, I guess. Well, at least the first one, we would know it would be directly below it, right? Because we know it's walls surrounding. So we could move. I guess we could just have an if check. We move into the next array. Then if the same index that we used previously, right, works in this next array, then that means we're going to proceed um, vertically. And if it doesn't, then we could check horizontally, right?
Let me really don't want to give. If I give you the biggest hint, I think you'll get it. You'll get it right away.
Never
How
be
would
surprised
you?
on how much I might not, Roosevelt.
If I give you this keyword, trust me, you'll get it. How would you navigate it on a Nintendo controller?
uh, down.
Mm-hmm. Think of it like that.
Um,
So if I start at here, I go down,
yeah.
down, down. Can't go down anymore.
Uh-huh.
So what do I do next?
Well, that's when we would check. But I guess we have to go either left or right?
Yeah.
Um, I guess what I'm thinking through is how do we check? Well, I don't know if that's important.
So here's the other thing too. Just think of it all as one data structure. Don't think of it as multiple arrays. Just think of it as one data structure with different indexes. I think that might be what you're kind of getting caught up on.
Yeah. Yeah. In my head, basically, if like if this is true, right?
Yeah.
Then all we have to do is go down one, right? So then if that's true, we go down, and then if that is true, basically we just want to check the same thing, right? This plus one, we don't even have to loop, right? Because if that's true, then great. Now we continue to move down, and then the else side be else. We need to be an else if, but essentially else. Then we need to see if horizontal, right? We need to check left or right. This is the part that I think I'm having difficulty thinking of how to express. Basically, we would just want to go. I don't know. Yeah, I think that's the difficult part for me. Is how do we start moving right?
All right. So with the pseudocode there, I think that's where you're getting caught.
In
So
which piece here?
on the else.
Yeah,
So
I
you
think
got it on
that's
the
the difficult part.
you got it on the vertical, but how do you traverse the horizontal?
Right. Oh, I
You
guess.
swap the indexes.
Yeah. So.
No.
No.
No. Okay. So if vertical plus one is how I move down.
Yep.
Right. I. So that means I'm in. Here's the row I'm in, and
Yeah.
I'm staying in the same column, right?
Mm-hmm.
If I wanted to move to the right, how would I do that? I'm sorry, rerow column. I'm confused with the two. If I want to stay in the same column, here's how I move down. If I'm
Yeah.
gonna stay in the same row, how would you move across that row?
Just add one. Well, that's what I thought with the +1 here, right? Plus, if we add one, if this was 2, right?
Yeah.
Now
So
this is going to 3, which I guess would be looping with the way that I originally had it, right? Is like we have to go back into a loop.
yeah. So I think you want to track your current coordinates. So I think that's the part that you're kind of missing.
Okay. Track the current coordinates.
Yeah. So after I move down, my new
Yes.
current coordinates are, that, and then go off of those
Yeah.
current coordinates and go from there.
So basically, like this same type of thing, last or current, right? So whatever this is, I think it makes more sense. Maybe this is bad, but basically, one represents moving vertically, one represents moving horizontally, right? So if this is the current coordinates, if so, same type of idea. If this +1 equals 0, then this would be now +1, right?
Yep.
And then else let's go the other direction, right? Well, I guess just knowing that there's dead ends, right? We really want an else if that does the same thing, but for else if this +1 equals 0, right? Then same idea. We're going to take this and increment the horizontal +1. That makes sense to me with my messy pseudocode. Does that make sense to you? Does that track?
Yeah. So that's how you move, down and to the right.
Yeah.
Okay.
Great.
So what if you have a case where, let me open up the coding on my side. The third row, the second from the last input.
This one?
Yep.
Line 12.
Yep. How would you move in that case?
Vertically, right? Because yeah.
But how would you move vertically?
This same.
But look how you would get there.
Oh, we'd have to go back.
Actually, that was a bad example. It should have been 15, really. But I'm actually not even 15. That would
12,
be 13. Yeah, 12, 4. Yeah.
Right. If we have to go up, right, then we'd have to decrement.
Yep.
Interesting. Okay. Well, I can think of basically we plot out every path in the same type of thing, right? If else, basically if vertically -1, right? If +1, else if, doing that whole plot. But I'm sure there's a better way. Like I feel confident I could write out the rest of that to basically check each direction.
Yep. So that's actually what you want to do. Checking each direction, vertical +1, vertical -1, horizontal, vertical, horizontal +1, horizontal -1. That's how you navigate through the maze.
Great. And I'm just trying to think of the case here in which this would be correct. Basically, we would move left, right? Depending on which check came first, right? Potentially we would move left, and then it would check through nothing, and then we could have an else that would basically be else. Well, no, because it would hit this, basically this one, right, to get us back.
But how would you get back?
Yeah, I'm trying to think, because otherwise we could get in a infinite loop. I believe, right? If we just, depending on where the checks came in, if the check to go left, and then we could just go left and right, left and right.
Yeah. So there's a implicit way of doing this, and there's an explicit way of doing this.
The way I would think is making some type of else clause that basically, I don't know exactly how I would write that.
Do you need an else clause? So how would you track the current path you're in so that you can actually print out the path at the end?
Oh, yeah, I was thinking basically adding each index to an array. Basically, each time we update this value, right? Also doing path, right? Array dot push I, right? Or whatever.
All right. So you have it. You put the data structure in, but you didn't call it by its actual name.
This array?
Is that an array? Or is it a stack?
Oh, yeah, I guess that makes sense. We would want, yeah, it's a stack by the nature that we're only adding things to it, right? We're never.
Yeah. So how would you think, like, how that works? So you put the first coordinate in, push down the stack, keep going down.
Yeah.
And then you get to that 1. So that's your current coordinate. What would you do then? So that coordinate of that 1's on the stack already.
We would just pop it from the stack.
Yep.
And then we would go the other direction, right? Or start to basically do our checks the other direction.
Yep.
Interesting. And then to avoid a loop like this, well, I don't know.
Yeah, I mean, so you say it's a dead end, pop it off the stack, and then check the other way.
Yeah, that makes sense. Yeah. Okay. Cool. Well, I think that's the pseudocode. I clean these up always, and then I'll push a solution. Yeah. But without me writing the big if else tree. This makes a lot of sense. So I think that, as funny as it sounds, the Nintendo, like, how would you move? That made the most sense to me. Of like, oh, we just got to go down and then right and then back up. I think I was worried too much of I was thinking of that as how do we track it at the same time as we're moving, but basically we can think about that later after we figure out how do I traverse this.
Well, right? That's the thing with the stack. You just print out the stack, right?
Yeah.
At the end. Yeah. So I'm not much time. I think we only have about 10-15 minutes left.
Yeah.
So I mean, we can walk through it, kind of from a high level. So I said there's 2 ways to actually do it. Yeah. There's an explicit way and there's an implicit way to do it. So the explicit way that we did it is using an actual stack.
Mhm.
The implicit way that you can do it is using recursion
Yeah.
and
Right.
then backtracking. So I didn't want to say, oh, well, how do you backtrack? Because immediately once I said backtrack, you would have gotten recursion. So
Yeah.
a
Yeah.
problem like this, you know, it's simple, but it also isn't so complex where you need to have knowledge of very complex data structures. I've seen this done, stack, queue, however, you want to do it. So it's literally a move here, testing it, texting that the next position, put it on the stack. If it works, keep it on the stack. Go ahead, go down, put that one on the stack. If it doesn't work, okay, pop it off the stack, go back, test the next direction, and that's how it, normally go. It could be, hey, test down first. Down doesn't work. Test right, test left, test, and you don't want to do up because that was your previous position. So
Yeah.
just making sure like it doesn't go back to your previous one. So that's how you could, walk through on it. I think the only things that you're really missing is just testing the bounds.
Yeah.
That you're not outside the array.
Oh yeah. Yeah. Good point. Cool. Yeah. My brain hurts enough. I don't know if I'd want to try the recursion side, but I can see how it would be. It almost seems like the solution would probably be simpler, right? But maybe less lines of code from a recursion standpoint, right? It might be a little bit more straightforward.
Yeah, I mean, if you used, essentially using stack, using terra recursion, if using, a more, the more, the traditional recursion you're thinking of, we're not using a loop. Yeah, there's going to be less code, but I mean, you can accomplish it either way, because either way, it's still using stack behind the scenes, even with recursion. It's just you're putting functions on a stack instead of, um, instead of the numbers themselves.
Yeah.
So I mean, there's definitely different ways you can do it. You do a while loop, and just say, okay, while I don't have my final current position isn't a 0 in the last array, and kind of go through there and use the stack that way.
Yeah.
Or you could just do the recursion, like I said before, do the recursion piece and just have all that return, with, hey, here's the answer, and kind of output it that way.
Yeah.
But like I said, once you get the answer to a problem like this, they get progressively easier over time.
Yeah. Yeah. And I feel like that's the case with many. There's a handful of kind of the same type of like mental, oh, this is how we have to think about this thing, and this is the direction to solve it. And like once you start to stumble across those on various problems, you start to see patterns, right? And I think that's part of the reason why interviews or technical questions do get easier to solve, because you start seeing more and more patterns, and at least you have a starting point, and then you can just work from there rather than trying to get to that starting point while you're trying to answer the question too, right?
Yeah. So I mean, honestly, I made this one is relatively simple. I could have, multiple paths.
Yeah,
I
yeah,
could
yeah.
have it beyond, so the top line, I could have it, starting on the side. With this one, it was just, it's just an example of, some of the questions that interviewers like to give,
Yeah.
with just like finding things like pass through a maze, or, another one that I like to ask is, okay, this represents a map. How do you, a map, and the ones represent landmass. Okay, find me the largest landmass, or find me the count of the land masses in there. And like, here's how you want to go. You navigate, up, down, left, right. So this one it's a little bit more interesting, because I think like this is one of the ones that like you see it, and once you see it, you kind of don't fall into traps later on when you see something similar,
Yeah.
to it like this.
Yeah. Great. Well, I appreciate it. I feel like I've learned, at least maybe we've quelled some of my fears of tutorial array questions. So that's
Yeah, I
great.
mean, and the thing is, like, if you ask questions, it's not like, a good interviewer won't hang you out to dry.
Yeah.
I didn't. Oh, I'm gonna say no, that's not right. It's like, okay, well, how do you think of it, this particular way? So
Yeah. Great. Well, thank you so much, Roosevelt, for being on the show. Anything else to add? Any other tips? Anything to plug? Sure you're hiring.
Yeah, definitely hiring for a lot of positions. Definitely go to dividos.com and check out some of the open positions there. Hiring software engineers, data engineers, and on product side as well.
Great. Well, everyone, check out Dividos. Look at the careers page. Roosevelt team specifically is the customer onboarding.
Customer enrollment team.
Customer enrollment team. So that's great. And then I'm sure that people can find you on LinkedIn and Twitter and anywhere else on the internet.
Yep.
Cool. Great. Well, I appreciate it.
All right. Thank you.
Thank you for watching the technical interview portion of the Professional Technical Interviewee. If you want to tackle this interview question, you can find it at github.com/professional technical interviewee. New episodes are released on the first 4 Thursdays of each month. Find us on YouTube at youtube.com/Dorsett or on Apple Podcast or Spotify. Make sure you subscribe so you don't miss out on new episodes. And remember, keep practicing.